my name is Nadi. My group members are Sean, Norelli, and Luis. The title of our research is Identifying Gender Mismatches Between Social Media Users and the U.S. Population. Social media websites are a popular way for users to connect, communicate, and share content. Due to the popularity of these sites, data from our users offer the opportunities for researchers to examine a sample population. If the sample is not representative of the entire population, then there's a proxy population mismatch. Therefore, we want to know, is Twitter data a good sample of the U.S. population? Our goal is to determine the demographics, more specifically gender, in Twitter by using the user self-reported first name and grammatical and syntactical patterns. Then, we will compare the gender demographics to the 2010 U.S. Census. Previous efforts have been made to study the demographics in social media, including gender. Some researchers have classified a Twitter's users' gender by assigning a score, while others have used machine learning algorithms to analyze tweeting text, names, surnames, and profile descriptions. In order to determine the difference in the gender of the populations, we need to classify each user as male or female. We will determine the gender score of the user's self-reported first name being a particular gender by using the Social Security Administration name data. For these users, we will specify a training set to our machine learning model to determine gender, given a parsed-speed representation of the profile description. The models will then be applied to the unclassified users to determine their gender. Then, using a chi-square test, we will determine if the Twitter data is representative of the U.S. population. So now that we've seen an overview of our methods, we'll take a look into our data. The time frame for our Twitter data is 12 a.m. to 5 a.m. Eastern Time on New Year's Day 2015. The location, the United States. The following tables shows the total unique users and the total unique users with profile descriptions for our Twitter data and our filter data. The Social Security Administration name is the list of names on Social Security cards for babies in the U.S. between 1880 and 2013. The list contains 92,600 unique names. For the 2010 U.S. Census data, we have a population size for ages 10 and above given by the following amount. Then the next amount shows the males and females population. I'll then let Sean talk about the gender score.
In order to classify users, we first take a user's self-reported first name and search for it in the Social Security name database. The frequency at which this name appears as a male or female name determines its assigned gender. Then we take a user's description and run it through a parts-of-speech tagger trained specifically for Twitter. Once we get the string of tags back, we convert it into a frequency vector as such. I love bikes, games, swimming, and traveling converts to personal pronoun, verb, noun, punctuation, noun, etc., which comes out to be as a frequency vector as 1 personal pronoun, 1 verb, 4 nouns, 3 punctuation, etc. The Kobrov-Smirnov test was performed in our dataset comparing male and female sections to determine which features of the dataset are most likely to determine gender. In our case, it is common noun, emoticon, and punctuation. Our machine learning pipeline is as follows. From our classified users, we create testing and training datasets. In the interest of time, we only discuss the most accurate 3 machine learning models. A decision tree classifier learns rules or generalizations from data. It organizes these rules into a tree-like structure and uses that tree structure to predict data. For instance, if personal pronoun is greater than 2, then branch right. If not, branch left. A random forest of decision trees combines multiple decision trees made from a sample of the training set with replacement. The node split, instead of, in my previous example, using personal pronoun as the best performing feature for a node split, a feature is selected at random. This corrects the overfitting of a regular decision tree. The k-nearest neighbor algorithm uses a training set to cluster together similar vectors based on a distance metric. It normally uses Euclidean distance, but other metrics are available, such as the Hamming distance. It's able to change high-dimensional data into clusters where descriptions that are closer together in terms of parts-of-speech syntax are grouped in the same cluster. The size of the clusters is determined by the square root of the length of the dataset.
In order to compare our results with the 2010 census, we will be using the chi-square statistics test. This test consists of 2 hypotheses, the null hypothesis, which states that there is no significant difference between the populations and the alternative hypothesis, which which states that there is a significant difference between the two populations. We will be computing our chi-square statistics by the following formula, where also y refers to the observed frequency and e sub I refers to the expected frequencies. We will be displaying our results in this 2x2 table as shown above, and we will be able to compute our chi-square statistics by the following formula. After we compute our chi-square statistic, we will refer to the chi-square statistic table to determine a p-value. If the p-value is greater than 0.05, we do not have enough evidence to reject our null hypothesis, but if p-value is less than or equal to 0.05, we accept the alternative hypothesis. After we use the Twitter user's first self-reported name and run it to the Social Security name database, we were able to classify approximately 11% of our users to be male and approximately 11% to be female, and the other 77% are unclassified. We will only focus on the classified users to compare our results with the 2010 US Census. By the following frequencies on the table, we were able to compute a p-value which is significantly less than 0.05. Therefore, we have enough evidence to reject the null hypotheses, and we accept the alternative hypotheses. Therefore, we can determine that we have a gender mismatch between the Twitter population and the 2010 US Census population. Once we used our classified users to train our machine learning algorithms, we were able to identify an accuracy score for each machine learning algorithm. As you can see, the highest accuracy score is 0.8022, which is from the random forest classifier. Louise will now talk about this classification.
So after we apply the random forest classifier to our entire data set, which consists of users who tweeted in English, live in the United States, and contain a profile description, we derive the following results. We can see that approximately 40% were males and the remainder 60% were females. This amounts to approximately 98,000 males and the remainder 150,000 being females. Next, we compute a chi-square statistic similar to the one we did before. We derive the expected frequencies by the 2010 United States Census data, and we derive the p-value that is significantly less than 0.05. Therefore, we reject our null hypothesis and we accept the alternative hypothesis, claiming that there is a significant difference between the proxy population and the US population. So we have identified a gender mismatch. Just to recap on the procedures we took, we were able to calculate a gender score from the Social Security name database, and we assigned a name and gender given that the gender score was significantly or equal to 0.89. We use machine learning models based on the parts of speech vectors obtained from the profile description. We applied the models to the entire filtered data sets, which included users who tweeted in English, lived in the United States, and included a profile description in their Twitter user profile. And finally, we used a chi-square statistic to determine if there is a significant difference between the proxy population and the US population. Overall, we were able to identify a gender mismatch between our Twitter population and the US population. We did notice a significant difference between syntax among males and females, and our result contrasted significantly to our previous methods that we had used prior to this. We'd like to give a special thanks to the Math Association of America, National Science Foundation, and Brand